Okay, the point number 6 is types of satellite orbits. The types of satellite orbits is nothing but what you have seen what is meant by orbit. Orbit is nothing but it is going to maintain its path. Satellite is going to maintain its path, that is called as the orbit. In this orbit, there are mainly three types of orbits. One is low Earth orbit, one is medium Earth orbit, and third is geostationary orbit. These are the three orbits: low Earth orbit, medium Earth orbit, and last is geostationary orbit. And satellite orbits, it is a path. See here, the diagram is saying orbit is path traversed by a satellite. When there is a circular in shape, one is elliptical in shape, and always the satellite is revolving in its elliptical in shape. That is called as, it is also elliptical, is also a equator of the earth, equator of the earth. And next, these are some of the satellite orbits. One is equatorial orbit satellite. There is a earth and there is a orbit. The orbit is in equatorial plane, that is in elliptical in shape. One is circular in shape, that is equatorial orbit satellite. And the second B, inclined orbit satellite. It is somewhat in angle, that is in 60 degree, 30 degree, 90 degree, 180 degree, 270 degree, and 360 degree. It is revolving in this way, that is inclined. It is called as inclined. That is inclination angle we have seen in orbital parameters. That is inclined orbit satellite. Inclined orbit satellite. And third is polar orbit satellite. The polar is always revolving in its 90 degree. It is always revolving in its 90 degree direction. That is polar orbit satellite. One is equatorial orbit satellite. It is a 360 degree. It is of 360 degree. Always is the equator of the earth. Inclined orbit satellite, that is an angle, that is inclination angle I. I is nothing but what? It has to cut the equatorial plane. That point is called as equatorial. That is inclination angle. That angle is called as inclination angle. That is I is nothing but it is of 30 degree, 60 degree, 90 degree. That is satellite is revolving in angle. A polar, it is always in 90 degree direction. That is what the different types of orbits: equatorial, inclined, and polar orbit. The first types of orbit is low Earth orbit. The low Earth orbit. Low Earth orbit is nothing but which is nearer to the Earth. Which is nearer to the Earth. Altitude, the height of the satellite from the Earth to the space. That is height of the satellite from Earth to the space, that is low Earth orbit, that is of 600 to 1000 kilometers. It may vary. The altitude, the height of the satellite from Earth to the space, that is 600 to 1000 kilometers. And revolution time, the 3 hours means in 8 times in a day it is revolving around the Earth. 8 times, 0 to 8, that is 8 times, that is 1 to 8, that is 8 times in a day. It is revolves around the Earth. You are seeing the number of satellites over here. That is 1, 2, 3. Okay. There are more number of satellites can be launched in the low Earth orbit. That is, more number of satellites can be launched in the low Earth orbit. That is, it takes one satellite can take revolve around the Earth 8 times in a day. Total 8 times in a day. And the height of satellite is 600 to 1000 kilometers, which is nearer to the Earth. That is called as low Earth orbit. The low Earth orbit is nearer to the satellite. And what are the advantages? What are the advantages of low Earth orbit? It reduces a transmission delay. Whatever the signal you are getting from the satellite, it is the delay will be little bit less. The delay will be little bit less. That is reduces the transmission delay. And it requires low transmission power. Why it is requires low transmission power? Because it is nearer to the Earth. The height of the satellite is very less. That is from 600 to 1000 kilometers. So transmission power, the transmit power it requires is less. That is, these are the two advantages of low Earth orbit. And what are the disadvantages of low Earth orbit? It will cover a small coverage area. It is using in rural areas, some of the urban areas where the population is less. They have started launching the satellite. That is, it will cover a smaller coverage area. Second one, a network of at least 6 low Earth orbit satellite is required to cover a region continuously. So we can launch a satellite more than that also. It requires, if you fix one area to cover the all the areas, it requires minimum 6 low Earth orbit satellites. And the third disadvantage is shorter lifespan. The age of the one satellite is in low Earth orbit is 5 to 8 years than geostationary satellites. Geostationary life, the age of geostationary satellite is high as compared to the low Earth orbit. The age, the minimum to maximum age is that is of 5 to 8 years. Right on this, the lifespan of low Earth orbit is, the low Earth orbit satellite is 5 to 8 years. And they are going to divide the regions in little, big and mega low Earth orbit. Small area, little bit big area and little bit big area. That is, they are going to divide the areas like this. Based on that, they are going to launch a satellite, and the height is of 600 to 1000 kilometers. It may vary, the distance may vary in low Earth orbit and medium Earth orbit. Not distance may fix, the distance will fix in geosynchronous, that is geostationary orbit. These are the advantages and disadvantages of low Earth orbit. Here, the height of satellite is 600 to 1000 kilometers and it revolves 8 times in a day. It revolves 8 times in a day around the Earth. Next, the second orbit is medium Earth orbit. In short form, it is called as MEO. Low Earth orbit, in short form, it is called as LEO. And medium Earth orbit, in short form, it is called as MEO. Medium Earth orbit. And height of the satellite of this is increases compared to low Earth orbit satellite. That is of 8,000 to 20,000 kilometers. It is far away from the Earth. That is, height of a satellite is 8,000 to 20,000 kilometers. You have to write down this. The revolution time approximate 6 hours. It may revolve around the Earth for 2 times or 4 times in a day. Revolves around the Earth in 2 times or 4 times in a day. This is what altitude of the Earth is. 8,000 to 20,000 kilometers. The height, it revolves around the Earth in a 2 times or 4 times in a day. That is medium Earth orbit. These orbits are primarily reserved for communication satellites. Whatever you are getting the signal for communication, whatever you are doing, the communication from one point to the multiple points, whatever is speaking, whatever calling is going on only because of this medium Earth orbit. These orbits are primarily reserved for communication satellites that cover from north to south pole. That cover from north to south pole. Unlike the circular orbit of the geostationary satellite and medium Earth orbits are placed in an elliptical. Both the geostationary and medium Earth orbit are placed in an elliptical orbit, that is an oval shaped orbit. Approximately a dozen medium Earth orbiting satellites are necessary to provide continuous global coverage 24 hours in a day. It is going to, we can launch a satellite more than 12. We can launch a satellite more than 12. It is going to give the signal for 24 hours in a day. All the satellites are giving a 24-hour signal, and all the satellites are giving a signal very properly if the satellite is nearer to the Earth and somewhat far away from the Earth. Your signal will be very accurate. The somewhat delay, that is 0.33 or 0.33 millisecond, that is the less delay will be there as compared to geostationary satellite. Geostationary satellite, the delay will be more. The delay will be more in geostationary satellite compared to low Earth orbit and medium Earth orbit. Next, what are the advantages? What are the advantages of medium Earth orbit? Slightly longer propagation delay, approximately 40 milliseconds. As compared to low Earth orbit, it is less delay, and compared to medium Earth orbit, it is slightly longer delay, slightly longer. As the height goes on increases, delay increases. Height increases, the delay will be increases. Slightly longer propagation delays, approximately 40 milliseconds. Second point, slightly higher transmission power required. As we required, it is in the low Earth orbit, we require a low transmission power in low Earth orbit. It requires somewhat slightly medium high transmission power is required. Why? Because we have increases the height. We have increases the height of the satellite from the Earth. So we require higher transmission power. That is, these two are the advantages of medium Earth orbit. Next, the disadvantages of medium Earth orbit. That is, first point is coverage spot greater than a low Earth orbit, but still less than geostationary orbit. Spot is nothing but if you fixed one of the area to cover that area, it is not possible to cover a low Earth orbit. The medium Earth orbit will cover a spot areas. We can mention, we have mentioned the spot area. Maybe the low Earth orbit will not cover, but medium Earth orbit cover the spot areas. That is the greater than, that is still less than geostationary. The multiple medium Earth orbit satellites are still needed to cover a region continuously. If you want to increase the number of satellites more and more for launching the satellite in medium Earth orbit, if the more and more medium Earth orbits are launched, we can cover a good coverage region in the of the Earth station. And last disadvantage is it requires handovers and satellite tracking are still needed, hence it is high complexity. The handover is not that much good as compared to low Earth orbit and as compared to geostationary orbit. Handover is nothing but what? When in mobile communication, when the user is moving from one base station to other base station, that is, you are going to change the channels, you are going to change the frequency band, you are changing the base station, that is called as handover. And satellite tracking are still needed. That is not that much good of tracking the satellites. So that is can be improved. That is a little bit, they are saying, high complexity. These are the advantages and disadvantages of medium Earth orbit. This is very important. Geostationary Earth orbit. You have seen the low Earth orbit, that is LEO, and you have seen medium Earth orbit, that is MEO, and last is geostationary Earth orbit, that is GEO. What is stationary? The stationary is nothing but that is fixed, that is constant. Stationary is nothing but fixed. It has to maintain its orbit in a particular path. It does not change its path. It does not change its path. Mute yourself. Okay. Geostationary Earth orbit, the altitude, the height of this low Earth orbit is near about 600 to 8,000, I think, and second is 8,000 to 20,000 kilometers. Altitude is of 35,786 kilometers from the Earth's surface. 35,786 kilometers above the Earth's surface. Revolution period, same as period of Earth. Earth rotates in a day and the geostationary satellites are rotating around the Earth in a day itself. For 1 day it takes to revolve around the Earth. The satellite in geostationary Earth orbit appears to be stationary over a fixed point on the ground. If you see from the Earth station to the geostationary Earth orbit satellites, it looks stationary. It does not revolve. It does not move from anywhere. If it is moved, you have to control from the Earth station. It has changed its path. It has changed. If it is changed its orbit, you have to control from the Earth station itself. Okay, that is, it looks like a stationary orbit. It is a fixed in the path. Whenever they are launching the satellite, they have to fix the orbit first. The scientists have fixed the path of the satellite. It has to go there and it has to take that path. It has to start revolving around the orbit. That's the main function of this geostationary Earth orbit is it has to maintain its path itself. It is to be stationary. So that name is called as stationary. Stationary, that is fixed. See here, this diagram is you are seeing that is there is a Earth, only 3 satellites are there geostationary, not more than 3 satellites. Earth is there, the one is at the left side of the satellite, top, and the right side of the top satellite, and below the satellite. These only 3 satellites are required in geostationary Earth orbit, not more than this. If you want to see any live cricket, any live speech, that is only because of this geostationary satellites. It has to grab the information, it has to grab the signal from the other countries. It has to grab the signal from the other countries. These 3 satellites are linking to the other country satellites. These 3 satellites are linking to the other country satellites to receive the signal from the other country and give it to the our country. That is the only function they are using a geostationary satellite, which is far away from the Earth station. So it is giving the signal whatever happens in other countries. That is only because of this geostationary satellite. Only 3 satellites are required in geostationary. One geostationary satellite covers 1/3 of the Earth surface using fixed antennas at the Earth station. Listen, one satellite is going to cover 1/3 of the Earth, and other satellite is going to cover 1/3 of the Earth, and third satellite is going to cover 1/3 of the Earth. If we combine all these satellites, it is going to cover the whole Earth. It is going to cover the whole Earth. One satellite is going to cover 1/3 of the Earth, and second 1/3, and third 1/3 of the Earth. So it is fixed using the fixed antennas at the Earth station. Whatever the signal is getting from the one satellite, and that signal will go to the Earth station, and the second signal is getting from the second satellite, that goes to the Earth station, and whatever the signal getting from the third satellite, that goes to the Earth station. These 3 satellites will cover the whole Earth station, the whole Earth station. That is the important function of geostationary satellites. Important function of geostationary satellite. Next point. So 3 satellites requires to cover the entire Earth. Not more than 3 satellites in geostationary. Requires only 3 satellites to cover the entire Earth. And next point. Geostationary satellites are commonly used for communication and weather observations. Geostationary satellites are commonly used for communication and weather information. Whatever the weather information we are getting nowadays, there will be rain after 2 hours. There will be a monsoon after 2 days, 3 days. That information they are getting only because of geostationary satellites. After 1 month, there will be a raining this much amount of millimeter. After 2 days, there will be raining this much amount of millimeter. That information are getting only because of this geostationary satellite. All the communications are going on, and we are seeing all the TVs, television, whatever is going on, communications, only because of this geostationary satellites. So geostationary satellites are commonly used for communications and weather observation. Next point. The typical services like expectancy of the geostationary satellite is 10 to 15 years. So age of this geostationary satellite is 15 to 10 to 15 years as compared to low Earth, medium orbit. The age of geostationary satellite is high. It has a maximum capacity to life by for 10 to 15 years. Whatever they are going to install in that, it has to be the more effective, that is, it is going to live for 10 to 15 years of Next, what are the advantages of geostationary satellites? What are the advantages of geostationary satellites? It covers a large coverage area. It means what? The one satellite will cover 1/3 of the Earth, second satellite will cover 1/3 of the Earth, and third satellite will cover 1/3 of the Earth. So the three satellites are going to cover a whole Earth station, a whole Earth station. So it is geostationary satellites are used for large coverage area. Second advantage, geostationary Earth orbit satellites have a 24-hour view of a particular area. It means what? One satellite will cover 1/3 of the Earth. So whatever the area it is covered, the one satellite, it has to be particular view on the particular area itself. Particular view will be particular area itself. That is going to cover 1/3 of the area. And the second satellite, there are mainly three satellites. One satellite will cover 1/3. That is only fixed on that particular area. Second satellite, that is going to cover 1/3 of the Earth. That cover will be covered by second satellite. And third satellite will cover 1/3 of the Earth. That satellite will be focused only on this particular area. So all the 24 hours they are going to view a particular area itself. That is the main advantage of geostationary orbit. What are the disadvantages of this geostationary orbit? Propagation delay is more. Why this propagation delay is more? The height of the satellite from Earth station to the space is very high. So whether there is a change in the weather condition, you are getting the signal. You are not getting your TV signal at the time of raining. At the time of very rainy, there is a weather changes. If weather changes, immediately you will get one signal. Due to bad weather, the signal is lost. Due to bad weather, the signal is lost. Please check the connection. Please check the connection. You are getting the signal at the time of rainy season in your television. So that is only because of the weather condition. If the weather changes, there is no signal you are getting. That is propagation delay is more. Where if the weather changes immediately, you are getting the signal immediately. So at the time of bad weather, there is no signal will be there at the Earth station. So one of the disadvantage for geostationary satellite is propagation delay is more as compared to low Earth orbit and as compared to high Earth orbit, medium Earth orbit. One more disadvantage, as the distance is more, signal at receiver is very weak. Whatever you are getting the signal, it is okay, but distance goes on increases, the signal at the receiver will become weak because of the bad weather condition itself. Only because of the noise present in a particular signal, the signal will become weak. That is one of the disadvantage. Not that much disadvantage, that is a minimum disadvantage of satellite, that is geostationary satellite. Next disadvantage is geostationary satellite orbit satellites centered above the equator have difficulty broadcasting signal to near polar regions. Polar regions is nothing but what? When it is revolving around in its 90 degree. When it is revolving around its 90 degree, it is difficult to broadcast a signal. It is difficult to broadcast a signal. If it is slightly changes direction in an inclination angle, if it is rotating around its equator, that is in 360 degree in the oval shape, that is in elliptical shape, the signal will be very quality, that is very high. But it is revolving in polar regions, that is in 90 degree direction, the signal quality will be little bit less. That is one of the disadvantage of geostationary satellite. These are the three main Earth orbit we are using. One is low Earth orbit, one is medium Earth orbit, and one is geostationary Earth orbit. We have seen what is the height of the satellite of low Earth orbit, how many times it is going to rotating, that is we have seen in low Earth orbit, and medium Earth orbit and the height, what are the advantages, how much time it is going to take revolve around the Earth, disadvantages we have seen. And in geostationary Earth orbit, you have seen only 3 satellites are required, not more than 3 satellites. One satellite is going to cover 1/3 of the Earth, second satellite is going to cover 1/3 of the Earth, and third satellite is also covering 1/3 of the Earth. So all these satellites is going to cover the whole Earth station. That is geostationary satellites. We have seen the advantages and disadvantages of geostationary Earth orbit. And what are the frequency bands? What are the frequency bands for satellite services we are using is, the bands are different. That is, bands are L band, S band, C band, Ku band, and Ka band. The downlink and uplink in gigahertz. Downlink and uplink, always the frequency band is in gigahertz, keep in mind. The L band is of 1.5 for downlink, and for uplink that is of 1.6 for uplink. For S band, 1.9 gigahertz to 2.2 gigahertz, because these frequency bands are using for low Earth and medium Earth orbit. Low Earth and medium Earth orbit, and the bandwidth of this is very less. That is, bandwidth for L band is 15 megahertz, bandwidth for S band is 70 megahertz, and C band, Ku band, and Ka band, these frequency bands are used for medium and geostationary Earth orbit. C band, Ku band, and Ka band, these bands are used for medium Earth orbit and geostationary Earth orbit. Downlink for this is 4 to 6. We have already seen the mobile communication also, and now also we have studied. That is 4 for downlink, 6 for uplink. That is the bandwidth is of 500 megahertz. And Ku band, downlink is of 11 gigahertz and uplink is of 14 gigahertz, and the bandwidth is remains same. That is for Ku band, that is 500 megahertz. And Ka band is of 20 gigahertz for downlink and 30 gigahertz for uplink, and the bandwidth is increases as the satellite height is goes on increases. The bandwidth is of 3500 megahertz. Bandwidth is of 3500 megahertz. These are the frequency bands used for the satellite services. What are the services it is going to give? One is fixed satellite service, broadcast satellite service, metropolitan satellite services. All the services, these services it is going to give only because of this frequency band. These are the frequency band used for satellite services. Okay. For example, you can draw the diagram like this. This is a nodes diagram. That is, there is a Earth and one more low Earth orbit is there, LEO. That is the distance is of 500 to 1500 kilometer. And the second circle, that is in elliptical shape, that is medium Earth orbit. See the arrow mark, medium Earth orbit. The height is of 5000 to 12,000 kilometer. And the last is geostationary Earth orbit. The height is of 35,800 kilometer. May he will ask the question that give the comparison between low Earth orbit, medium Earth orbit, and geostationary Earth orbit. He will ask for 4 marks. Instead of asking the types of Earth orbit, he may ask explain the types of satellite orbit, or give the comparison of low Earth orbit, medium Earth orbit, or geostationary Earth orbit. Write down this table. The first parameter is satellite height. This is a common. You have to write the first satellite height is of 500 to 1500 kilometer for low Earth orbit, and medium Earth orbit is of 5000 to 12,000 kilometer medium Earth orbit, and geostationary Earth orbit is of 35,800 kilometers. That is the first parameter, height of the all the satellite orbits. Second, orbital period, how much time it is going to take to revolve around the Earth. For low Earth orbit, it is of 10 to 40 minutes for once in a revolution of the Earth. 10 to 40 minutes. 10 to 40 minutes. And medium Earth orbit, that is of 2 to 8 hours. Medium Earth orbit is of 2 to 8 hours, and geostationary Earth orbit, it will take once in a day, that is 24 hours. That is the time required to cover a satellite around the Earth. That is, next is of number of satellites. How many number of satellites can be launched in low Earth orbit is 40 to 80. 40 to 80 satellites can be launched in a low Earth orbit. In medium Earth orbit, we can launch 8 to 20. 8 to 20, we can launch a medium Earth orbit. Dhanure, mute yourself. 8 to 20, we can launch the satellites in medium Earth orbit. And geostationary orbit, we can launch only 3, not more than 3. Geostationary orbit, we can launch only 3 satellites. That is number of satellites. What is the life of satellite? Satellite life is of, in low Earth orbit, that is short. The age of satellite is less. Medium Earth orbit, little bit high, that is long. Geostationary orbit, that is very long, very high. That is, satellite life is short, high, very high. Number of handoffs, whatever the handoff you are taking nowadays to changing the location. In low Earth orbit, that is very high. In medium Earth orbit, that is low. Geostationary Earth orbit, that is least. It is not going to take over any handovers. Only handover functions will be going on in the low Earth orbit. Whatever your communication is, most of the communication nowadays, that is GPS, communication is going on only because of low Earth orbit. Number of handoffs, that is high, low, and least. And next parameter is propagation loss. There is a loss in the signal. Loss in the signal, low Earth orbit is least, very less. Loss of the signal is very less. In medium Earth orbit, it is a little bit high. The loss of the signal, that is signal coverage, is very high. We high in medium Earth orbit, and geostationary, that is very high, that is highest in geostationary Earth orbit. And last parameter is revolution per day. Revolution per day, that is, we are taking 8 times in a day, 2 times in a day, once in a day. It is going to revolve around the Earth 8 times in a day, and the satellites are going to revolve around the Earth 2 times in a day, that is medium Earth orbit. And geostationary Earth orbit, it is going to revolve around the Earth once in a day. This is what the comparison of low Earth orbit, medium Earth orbit, and geostationary orbit. Write down. Take this parameter, low Earth orbit, medium Earth orbit, and geostationary Earth orbit. Write down this. Very important point. I'll give you 2 minutes. Write this. Satellite height, orbital period, number of satellite, fourth is satellite life, number of handoffs, propagation loss, revolution per day. You have to write down low Earth orbit, medium Earth orbit, and geostationary Earth orbit. Make 3 columns. If you want to take that diagram, above diagram, you can draw that diagram also. Low Earth orbit, you have to draw once Earth, and next draw you have to draw low Earth orbit, that is elliptical. Medium Earth orbit, that is also an elliptical, and last is of geostationary Earth orbit, that is also elliptical. You have to mention the height of the satellite, that is from altitude. It is also called as altitude of the satellite, that is height of the satellite, that is 500 to 1500 kilometer, 5000 to 12,000 kilometer, and geostationary is of 35,800 kilometer. The most important point in this is what? Height is very important, and how many number of satellites we are going to launch, that is also important, and what is the life of satellite, that is very important, and revolution per day, how many times it is going to revolve around the earth, that is also very important. This is what the concept of types of satellite orbits. Okay, last point is remaining. Tomorrow we'll see that point number 7, that is launchers. This is the last point of unit number 1, launchers, and after this we solve the numericals based on the circular and elliptical orbits on Saturday, and I will conduct one test after this. You have to give me that test. I will tell you that when it is. This is what the point number 6 is of types of satellite orbit. We'll stop here. Tomorrow we'll continue. Everyone has to give your attendance. If it is missed, I am not responsible. Everyone has to give your attendance. Take minute, 1 minute or seconds gap. Everyone has to give your attendance.
Sir, Ashwini division CRN division 80.
Ashwini Patil.
We used to take attendance before the lecture. So ए डिव्हिजनच्या नाही टाकले त्यावेळी रोल नंबर तरी चालते, कारण इथं परत प्रॉब्लेम होते आणि बी दोन्ही येतात.
बघू राहू दे, टाकू दे.
फक्त बी वाल्यांनी रोल नंबर टाकत जायचं.
चालतं राहू द्या.